Hello students, in this session I will discuss increasing and decreasing functions. So first let us understand what is the meaning of increasing and decreasing function. So let us consider the graph of the function y is equal to x square in the interval -5 to 5. So let us draw the graph y is equal to x square. The graph of y is equal to x square is a parabola whose axis lies on the y axis. Now let us consider the interval on the number line from -5 to +5. And let us consider some points here: -4, -3, -2, 0, 2, 3, 4, 5 on the other side. So let us find the value of this function y is equal to fx is equal to x square at various points. When x is equal to -5, so let us make the table. When x is equal to -5, putting x is equal to -5, the value of y is equal to -5 square, that is 25. When x is equal to -4, then the value of y, putting x is equal to -4 here, value of y is 16. When x is equal to -3, the value of y is 9. X is equal to -2, value of y is 4, and when x is equal to 0, value of y is 0. So when we proceed on the number line from left to right, that is when the value of x is increasing, the value of y goes on decreasing. This length goes on decreasing. First it is 15, 25, then 16, then 9, then 4, and then 0. On the other side, means right side, let us draw the table again. X and y. When the value of x is equal to 0, value of y is 0. When x is equal to 2, the value of y is 4. When x is equal to 3, the value of y is 9. When x is equal to 4, the value of y is 16. And when x is equal to 5, the value of y is 25. So what we observe in this graph from -5 to 5, that the value of y from the interval -5 to 0, it goes on decreasing. And on the other side, on the right side, when the value of x we take from 0 to 5, it goes on increasing. So we can say that this function is from -5 to 0. In this interval, this function is decreasing. And on the right side, from 0 to 5, we observe that the value of y goes on increasing. When we increase the value of x, the value of y increases. So the function is increasing. So if in an interval the value of the function goes on decreasing, on increasing the value of x, the function is decreasing. And if the value of the function goes on increasing, when we increase the value of x, then the function is said to be increasing. Now in the whole interval, if we study, then this function is from minus 5 to 5. If we study this function, then it is neither increasing nor decreasing. Neither increasing nor decreasing. But if we consider the interval minus 5 to 0, it is decreasing, because when the value of x is increasing, minus 5, minus 4, then minus 3, then minus 2, then 0, the value of y goes on decreasing. And if we consider only in the interval 0 to 5, then the value of, when we increase the value of x, the value of y goes on increasing. So in 0 to 5 interval it is increasing, while in the interval minus 5 to 0 it is decreasing. And while in the whole interval minus 5 to 5 it is neither increasing nor decreasing, because there is no specific trend, means either increasing or decreasing. For some interval it is decreasing, for some interval it is increasing. Then we say that it is neither, in the whole interval it is neither increasing nor decreasing. So this was the basic concept of increasing and decreasing function. Let us add some more points in the increasing and decreasing function. Increasing function. So if we have a function y is equal to fx and we want to check this function in the interval a to b, which is in the domain of the function. Now let us consider the 2 points x1, x2, and x2 is greater than x1. Now if fx2, so let us consider any 2 points in the interval x1 and x2, and x2 is greater than, fx2 is greater than or equal to fx1, means on increasing the value of x, the value of the function is also increasing or equal to, then it is said to be increasing function. We can consider any point in the interval a comma b. So if if fx2 is always greater than for any point x1 comma x2 in the interval, and where x2 is greater than, fx2 is always greater than fx1, then we call it strictly increasing. And for the strictly increasing, the graph of the function is like this. It is like this. Means the value of y goes on increasing when we increase the value of x. This is the x-axis and y-axis. But if we have the graph like this, for some from a to b, for some interval it is increasing, then it is constant, and then again it is increasing. This is called increasing function. For some interval it may be constant, and in the remaining time it is again increasing. For in the beginning it is increasing, then it becomes constant for some time, and then it is increasing. So this is for strictly increasing. And this is a graph of increasing function only. So here now let us talk about the decreasing function. In the decreasing function, let us check in the interval a comma b, which is a part of domain. Now if on let x1 comma x2 belongs to this interval AB and x2 is greater than x1, if the value of the function is less than or equal to fx1, then we say that the function is decreasing. That is, on increasing the value of x, the value of the function is decreasing. So we can consider any interval, any 2 points in this interval a comma b, such that and x2 is greater than x1, then this is happening. And if fx2 is less than fx1, for this, in this interval, if we consider any 2 point and x2 is greater than fx2 is less than x1, then this is strictly decreasing. For decreasing function, the graph is like this. If we consider graph is like this, means on increasing the value of x is going on increasing. If we going in this direction, in the right hand direction, in the increasing x direction, the value of y goes on decreasing. So if we consider any 2 points, let it be x1 here, x2 here in the interval a comma b, then the value of fx2 is less than fx1. So it's simply only less than fx1, then it is strictly decreasing. And if it is equal to, like the graph is like this, if the graph happens to be like this, then it is again. So here the value is decreasing, then for some interval it is constant, and then again it starts decreasing, then this is the case, this is strictly decreasing. And in the second case it is decreasing. Now let us discuss the increasing or decreasing function in terms of calculus, in terms of derivative. If in an interval AB, which is the part of the domain of the function, if the derivative of the function is greater than or equal to 0, then the function in any interval, if this happens, then the function is said to be increasing function. And if in any interval this happens that the derivative is greater than 0, then the function is said to be strictly increasing in that interval. Third case, if in an interval the value of the function f dash x is less than or equal to 0, the function is said to be a decreasing function. And if in an interval f dash x is less than 0, then it is said to be strictly decreasing function. So let us understand why this condition. So for increasing function, as you know, the graph is going upward. So if we draw tangent at any point of this graph, it is always making an acute angle. Line is always positive. That is f dash x is greater than 0. So this is the case of strictly increasing function, that the derivative is greater than or greater than 0. But equal to 0, there are some certain points at which the tangent is parallel to the x-axis. At those points, or the function is constant for a particular interval, at those points the value of f dash x is equal to 0. That's why in the increasing function we put equal to 0 also. And in the decreasing function, strictly decreasing function, if we draw the graph of strictly decreasing function, it is like this. In that case, if we draw the tangent at any point, it makes obtuse angle with x-axis. And if the angle is obtuse, then the slope m is equal to tan of the obtuse angle, tan theta, and theta is obtuse angle, so the slope is negative. Or slope is also slope can also be calculated by the derivative of the function at a point. So the value of f dash x is less than 0. At some points it may be equal to 0 when the graph becomes stagnant. So the derivative is less than 0. So for increasing function, derivative is greater. For strictly increasing function, derivative is greater than 0. For strictly decreasing function, derivative is less than 0. For increasing function, f dash x is greater than or equal to 0. And for decreasing function, f dash x is less than or equal to 0. Now let us discuss some important theorems on increasing and decreasing function. So if we have a function, if we consider a function in the interval a b, which is the part of the domain of the function, and if this function is continuous in closed interval a b, and are differentiable in open interval AB such that the f dash value of f dash x in this interval at any point is greater than 0, then this function is let us consider this interval AB, then this function is increasing in closed interval AB. Similarly, if any function is continuous in AB, differentiable, that is, we can find the derivative in open interval AB, and this differential f dash x is less than 0 in this interval a comma b, then the function is decreasing in closed interval a comma b. So this was all about increasing and decreasing function. In the next part, I will discuss some important questions of increasing and decreasing function. So with this I conclude this session. Like and subscribe my channel for new videos and press the bell icon. Thank you.